Welcome to Lecture 12 in this series of lectures on statistical process improvement and statistical quality assurance. We're now talking about quantifying measurement imprecision, that is variation in measurement, and trying to partition measurement variation into a part that is attributable to differences between operators using a particular measurement device and sort of baseline or repeatability variation. The standard jargon is gauge R&R, and gauge R&R studies are a very important industrial tool, a very important industrial activity, and as I say, they are used to separate repeatability and reproducibility variation with the end of guiding how to improve measurement precision. If there's large reproducibility variation, that indicates that operators are using measurement equipment differently. Training, standard operating procedures might be applied to try to reduce reproducibility variation. If repeatability variation is present, that usually is too large. That usually indicates the necessity for basically improving the quality or overhauling measurement equipment. That is, it's fundamentally something that is going to require capital investment. A basic standard R&R study typically consists of multiple parts. Here, part 1 and part 2. We'll use the symbol cap I to stand for number of parts or items involved in the study, measured by some number of operators. Here we're imagining that there are 3 operators involved. We'll use the letter J to stand for number of operators, with each operator measuring each part some number of times, and here we'll call that little m, and in this case every cell here has 2 measurements in it. To be careful, we're triple subscripting things, so the first subscript on a Y, on a measurement Y, tells which row, which part. That is, second subscript tells which operator or which column, and then the third subscript says which measurement in a particular part, operator, cell is involved. If one had only a single row, then the methods of module 11 could be used, but it's more common in industrial context to involve multiple parts so that the study has a chance to involve the kind of variation in measurands that will be seen in application of the measurement device. Here is a set of R&R data collected in a IE 361 laboratory. They're here to provide an example that will be used both in this module and in subsequent modules. For the time being, let's just point out some characteristics of these example data. Look, for example, at this first part and first operator. In that first cell, the 2 measurements are identical. They're 0.52, so their average is 0.52 and their range is 0. So in that particular cell, there's indication of a fairly small repeatability variation. On the other hand, if one was to uh, change cells and perhaps look at operator 2 on part number 1, now for operator 2 on part number 1, the two measurements made by that operator are not identical. They're 0.54 and 0.53, and their range is not zero. And that non-zero range is indicative of so-called repeatability variation. There's not absolute consistency within a particular cell. There's some kind of basic baseline variation in measurements made using the particular caliper that was involved. The difference between the Y bars for operator 1 and operator 2 most obviously is produced by differences that we would call reproducibility differences. But one has to be a little bit careful because the Y bars will differ not only because there's consistent differences between the operators, but also because of random variation within the cell that's coming from repeatability. So I'm saying that the difference here and there is potentially traceable to not only reproducibility variation but repeatability variation, and one has to be a little bit careful about how one thinks about that. To continue on with some summary statistics for this data set, one might, for a given row, look at the Y bars and ask how much do they differ? What's their range? And so this Y bar, this Y bar, and that Y bar have a range of 0.03. And that is some kind of a summary of operator to operator differences plus some repeatability difference. If I look on the last row, for example, the 0.55, the 0.545, and the 0.555, sorry, 0.55, 0.545, and 0.555 have a range of 0.01, and so we're going to call those ranges for a given part. We're going to call those ranges in Y bars for a given part. We're going to call those deltas. When we average them, we'll call that cap delta bar. That's a measure of reproducibility plus repeatability variation. The average of the within cell ranges, R bar, is a measure of repeatability variation alone. We're going to talk briefly about how one might use those statistics to make R&R inferences. Before we can do that, we have to talk about a probability model for this context, and that comes up in module number 13.